Adding and subtracting fractions. What do you need? Now I know some people think you need a 5-time comma factor, but what do we actually need when we are adding fractions? A common denominator, right? Common denominator. So if I was adding these two fractions right here, how would I do that? Don't tell me what the answer is, tell me how to do it. Add the numerator, and what do I do with the denominator? Just leave it, just keep it, right? So 5 over 7. So the steps that we took were to add the numerators, and what about the denominators? Leave the denominators. Or keep the denominators, right? Keep it. So would we do the same steps for rational expressions as we do for regular fractions? Okay, so how would I do this problem right here? I'm so afraid what you're going to say for the numerator. I'm so afraid. Oh, good. That's exactly right. What have other people said today? 2x, right? 2x. They haven't said x squared, but they've said 2x a lot. I'm adding, not multiplying, so my numerator should be x plus 2. Now, somebody earlier also said 2 plus x. It's the same thing, but typically we what? Put the x first, right? Okay. My denominator should be 2x minus 8? No? Oh, okay. X minus 4. And now we can cancel out the x's. Why not? 17 over 19, right? We can't do that. We can't cancel it out. We can't simplify those because it's part of another number. It's not a factor. Remember, factors are multiplied by each other. Numbers that are added or subtracted from each other are not factors. You okay with this? So this is the answer. Okay? What about this one? You know, in fact, what some people do when we're adding fractions and the common denominator is already there, they just go ahead and rewrite it so they don't forget or they don't mess with it later on. Okay? So that might be a good plan for you. So what do I do with the numerators? Combine them. We add them, right? So I have a 2x and a 5x. 7x plus 4. Or 4. 3 is close, but 4 is better. Okay? Any questions on that? All right, so what about number 2? How is number 2 different? It's subtraction. So what kind of rules or steps are we going to follow for subtracting fractions? Oh, so I subtract the numerators and keep the denominators? So what would I get as my answer? 5 over 11. So if I subtract the numerators and then keep the denominators again, right? Or leave the denominators. Leave them alone, for goodness sake. That's what I try to tell some of you guys sometimes. Leave me alone. This kid came to my door this morning during tutorials, and they said, "Do you know when my teacher's going to be here?" And I was like, "No." "Well, I just need some help with my math." And I said, "I could help you." And she said, "Are you any good at math?" And I had a kid, one of my kids sitting in here, and they just started cracking up. And I said, "Yeah, I actually teach Algebra 2 here." And she goes, "Yeah, but do you know Algebra 1? And then I was like, "Yeah, no, I'm not. No, I'm not kidding. I do know Algebra 1. Okay?" So then the kid came in here and I helped her with their stuff, and she was like surprised that I knew how to do that. It was pretty funny. Yeah. So I do. Yes, I do have my master's. But that doesn't necessarily mean I know Algebra 1. I guess. I don't think that kid knew I had my master's, so that's okay. All right, so how do I do this problem? I don't? Oh, okay. Okay. So I'm going to go ahead and write my denominator so I don't try to mess with it later. Just want to keep my denominator. And this is a subtraction problem. So this can get confusing if you let it, but you're smarter than it, so you're not going to let it. Okay? Here, what do you think the wrong answer is that people tell me a lot? 2x plus 20. Well, that's what they tell me. And sometimes they'll even tell me x plus 20, which is closer to right, but it's still not right. Why is it x plus 2? So 2x minus x is x. I agree with that. And 11 and 9 is 20. Okay, you guys remember that I know how to do this, right? Okay, I'm just trying to get you to talk about it, and you're doing a great job, but you're being a little attacking, so I just want to make sure you do remember that I do know how to do it. Okay, so I'm saying, not only do I say 2x minus x, I also say 11 minus 9. Okay, 11 minus 9 is what? 2. So let me show you what some people do so that they don't forget that. Isn't subtracting the same as adding the opposite? So what if I found the opposite of each one of these and then just added my like terms? Is that a little easier to see? Okay? You're more likely to remember the negative sign for the second term or the third term, depending on how many there are, right? Or the subtraction. And then we cross out the x's. No. What'd you do at school today? I told my teacher no. Okay. What about this one? Yes. I'm going to go ahead and write my common denominator. What about my numerator? Negative 8x. Ooh, plus 10, right? 3 minus a negative 7, so 3 plus 7. You got that okay? All right, so what about number 3? You have to get a common denominator. Don't tell me what the common denominator is. Tell me how to get the common denominator. You can, right? You can multiply to get a common denominator. What should be the common denominator? 8. Will I ever divide to get a common denominator? Probably not, right? Because will my common denominator ever be 4? If these were my two denominators, which they are, would my common denominator be 4? No, it's got to be at least as big as the biggest one, if not bigger. It's not going to be smaller than the biggest denominator. Okay? So what is my common denominator here? 8. So to get from 4 to 8, I have to multiply by 2. If I multiply the denominator by 2, I have to multiply the numerator by 2. Which makes this problem become 3/8 plus 2/8. And then we just follow the same rules that we've talked about already for examples 1 and 2. We keep our denominator and we add or subtract our numerators. Yes? So we need to find a common denominator. And then add or subtract. So if I'm looking at this first example right here, what would be my common denominator? I've heard 3. Is there any other possibilities? Okay, so if you think the answer is 3, what do I have to multiply this by to make it become a 3? If I multiply by 1, it's a 3x. If you think it's 3, what do I have to multiply this by to make it become 3? So is 3 our correct common denominator? No. It's not going to be smaller than any denominator we already have. So what would be our common denominator? How about 3x? Right? How do we figure out how to make them the same? Well, they already both have an x, so we know that's going to be part of the common denominator, right? This one has a 3 and this one doesn't. So shouldn't I multiply this one by 3 and wouldn't that be common? Yeah? So if I multiply this one by 3, I also have to multiply the numerator by 3. So my new problem is 5 over 3x plus 3x plus 3 over 3x. Correct? Keep my common denominator and combine my like terms in the numerator. So I should get 3x plus 8. What will people try to do right here? They'll try to get rid of the 3x's, won't they? Are we allowed to do that? Why not? 17 over 19, right? This is not a factor of the numerator. It's part of this number. We can't just get rid of parts of a number. We can only get rid of common factors. Everybody okay with that? At least for now? Okay. What about this one? What do you think might be the common denominator of this one? Well, do they have a common factor already? Well, that might help if I would factor this one to C, right? So I might have to factor before I start, right? Now, do they have a common factor? Yes, so I know that has to be part of the common denominator. Okay, is there something that one has that the other one doesn't? The 2. So wouldn't it be logical for me to multiply this one by a 2? Wouldn't that now be a common denominator? Okay, so if I multiply that one by 2, my common denominator is 2 times x plus 2. What does this one become right here? 18. So I have x plus 1, because this numerator didn't change at all, did it? So I have x plus 1 minus 18. X minus 17. Done. What will people try to do wrong right here? They'll try to take out the x's. We can't do that, can we? They're not common factors. You okay so far? Last example, number 4. 3 over 7 plus 2 over 5. Almost. That's very close. Between 7 and 5, what's my common denominator? 35. So how do I make 7 become 35? Times it by 5. And that's what you said, right? But if I multiply the denominator by 5, I have to multiply the numerator by 5. So what am I actually multiplying 3/7 by? Which equals 1. That's why I can multiply it by 5 over 5. I get to choose the value of 1 that I need, and I need a value that will give me a common denominator. Okay? What value of 1 am I choosing for this side? 7 over 7. Very good. So that gives me a new problem of, how about 15 over 35? Plus 14 over 35. That's all right. You're just ahead of me. What is 15 over 35 plus 14 over 35? 29 over 35. So sometimes when they have a factor in common already, because this isn't really 4 times 2, isn't it? Yeah? They already had a common factor of 4. This one just had an extra factor of 2, so I needed to multiply that by a factor of 2, right? Sometimes they don't have a common factor. So what did I multiply each of them by? The other one, right? A different number. This one I multiplied by 5. This one I multiplied by 7. When in doubt, multiply them together if you can't figure out the common denominator. It may not be the least common denominator, but it will be a common denominator, and you can get the right answer that way. Okay? So what are my steps? Find a common denominator. Denominator. And then what? Oh, wait, so it's exactly the same as the one right above it? Okay. Do they have any factors in common? Then what is my common factor? Or my common denominator, excuse me. What do you think it might be? 3x. Okay, so I'm going to go ahead and rewrite my problem with that of 3x and that of 3x. What do I have to multiply this first one by to make it become a 3x? A 3 over 3, right? 3 here and a 3 here. What do I have to multiply this one by to make it become a 3x? X here, x here. So my new numerator for the first fraction, 15. My new numerator for my second fraction, 2x squared. What's my new numerator for my answer? Ooh, that scares me a little. You can put 15 minus 2x squared, but typically what do we write first? We do write the x squared first, right? But tell me the sign of the x squared term. It's negative. It should be negative 2x squared plus 15, not the other way around. Okay? Are you okay with that? Was that just like a little mental pause in your something in your brain or something? Okay. We can hope. Any questions about that? All right. What about this one? Do they have any factors in common? Is x a factor? Is x being multiplied by the rest of the problem? No, then it's not a factor. Okay? So when in doubt, what do? Multiply them together. So this one's a 2x minus 1 over 2x minus 1. And this one is x plus 3 and x plus 3. So my new fraction for the first one, I'm going to go ahead and write it down below it if that's okay with you. 2x minus 1 times x plus 3 plus 2x minus 1 times x plus 3. I just went ahead and rewrote the problem with my denominators already there. What does my new numerator become in the first fraction? Good. 8x minus 4. And what does the second fraction numerator become? 21. So what is my answer? I keep my denominator. $15x. I heard it, just not loud enough. Minus? Minus or plus? Oh, plus. 17? Because you've got negative 4 and positive 21, so that's positive 17, right? Any questions so far? Add or subtract each set of rational expressions by finding a common denominator. Hint, it may help to also factor the denominators first. Well, let's try that. Can I factor this denominator? No. Can I factor this denominator? Oh, that's the difference of squares. I sure can. How do I factor the difference of squares? X plus 2 and x minus 2. Is there a factor that both denominators share? What is it? Then I know that has to be part of my common denominator. Is there a factor that the first one has that the second one doesn't? No. Is there a factor the second one has that the first one doesn't? Yeah, then that also has to be part of my common denominator. What do I have to multiply the first denominator by to make it become the common denominator? What's it missing? An x minus 2. So what is 2x times x minus 2? 2x squared minus 4x. What do I have to multiply the second denominator by to make it become the common denominator? Nothing, right? It already is the same thing. So what do I have to multiply the numerator by? Nothing. So now combine your like terms. What do you get? Good. Minus 3x. Good. Any questions? Look at number 6. What do I need to do first? Factor the denominators. So does this factor? What is it? So x plus 4 and x plus 3. Does this one factor? You can take a 2 out of it, right? They're both divisible by 2. So I get x plus 4. Do they share a common factor? Then that has to be part of the common denominator. Does the first one have one that the second one doesn't? So x plus 3. Does the second one have one that the first one doesn't? A 2, right? So that has to be part of it as well. So my common denominator is 2 times x plus 4 times x plus 3. Now, go back. What does the first denominator need that the common denominator has? Here's the first denominator. What's it missing? A 2, right? So if I multiply it by 2, I multiply the numerator by 2. What does the second denominator need? An x plus 3. So my first numerator then is what? 2x plus 12. And what's my second denominator? 5x plus 15. Right? Now I need to actually do the subtraction problem, right? I'm going to go ahead and copy my denominator, so it's there. Now, combine like terms. What do you get? Negative 3x minus what? Good. 12 minus 15, right? Any questions? Now, I want to talk about this real quick. It doesn't happen on this problem, but sometimes it might. What about if this x plus 4 was like a x plus 1 instead? Isn't there a common denominator in the numerator? Negative 3, right? If I factored it on negative 3, I would have an x plus 1. If I had an x plus 1 there and an x plus 1 here, what did we learn yesterday that we could do? We could simplify those, right? Because it's a common factor in the numerator and in the denominator. Now, it doesn't happen on this problem, like I said, but you got to keep that in the back of your mind. You got to simplify it at the end if you can. Okay? All right, last example. What should we do first? Factor. Does this one factor? 2 and 4, x plus 2, x plus 4. Does this one factor? Negative 3 and 2. So, do they share any common factors? X plus 2, so that has to be part of my common denominator. Does the first one have one that the second one doesn't? Then that one has to be part of my common one. Does the second have one that the first one doesn't? And then that one has to be part of my common denominator. Does that make sense? Are you lying? Okay, good. So what is the first one missing, if anything? X minus 3. What is the second one missing, if anything? X 3x plus 4 plus... So what's the first numerator become? We got to multiply that out, don't we? X squared plus 3x minus 3x, which is 0, and then minus 9, right? What does the second one become? 36? Yeah? What's left? Any questions? Can I factor this one real quick in my head? Multiplies to be 27, adds to be 9. Three and 7 are 21. So no, right? Can't factor it, so I don't need to worry about simplifying. That's the answer. Okay? Next page are your homework problems. Please circle these problems. 2 and 6, 3 and 7. 4 homework problems. Can you handle 4? All right. If you have any questions, come see me in tutorials.